can be equal to. These are very important, which will help us a lot in to proceed further. So I could have written directly the expansion of sine of a plus b. It is there in the bottom, but how it has come is we are trying to explain using this one. So let me take this. There's a line OM. So there's a reference line. OX is a reference line for us. The line OM, it makes an angle A. What I'm doing is I'm rotating here now. So earlier the line OM was along x-axis, so I'll rotate it. Now this line OM will make an angle A with the reference line OX. Then afterwards, further I'll rotate it. Then this line, now it will make an angle B with the position OM. Now sine of A plus B, I'm trying to ask. Okay, definitely as you rotate, what will happen to the height of the triangle? It's going to vary. So sine of A plus B will become compound angle. So sine of A plus B, what it? Sine A we know. If you know OM, you can get the sine A. You know this angle A, and you know OM. So what is the height of triangle? As you know it. Similarly, if you know ON, then what is sine of A plus B? Is what we are trying to calculate here. Okay, let's do one thing. So I'll draw from a line PT perpendicular to OM and PR perpendicular to OX. And next further, the TS will become perpendicular to OX and TQ I'll draw perpendicular to PR. And we'll define this angle SOT will become equal to A. And similarly, OTQ, so that this will become, again, it should be equal to A. And this angle is how much? This will be perpendicular, no, 90 degrees. So 90 minus theta. So this should be equal to A. So then QPT, angle QPT should be equal to A. I think this is very important. Try to notice here. From the properties of triangle, we have defined this relationship. Okay, after defining all these things, okay, let's get into one by triangle. So let's go for the triangle ORP. I have shown separate here. In the triangle ORP. So what is the angle? It will be A plus B. What do you mean by compound angle? Sum of two or more angles is called as compound angle. Earlier, what we have seen, sine A we have defined. Now sine of A plus B we are trying to define. So sine of A plus B, how much it is? So I have got a triangle here, ORP. Here, look at this triangle, ORP. Sine of A plus B, RP by O, RP by OP, opposite by hypotenuse. So what is RP? RP is here. So can we break up this RP as RQ plus QP from here, RQ plus QP, and OP as it is. And this RQ is parallel to TS, and both are of equal length. RQ equal to ST. So this RQ, we are replacing it as ST. Some changes, some replacement is being done. Then sine of A plus B, ST by ST plus QP by OP. Then ST by OP plus QP by OP. Let me divide and multiply by OT. This equation here. I'll divide and multiply by OT. Similarly, I'll divide and multiply by PT for this equation. This term, I'll divide and multiply by OT. This term, I'll divide and multiply by PT. Then ST by this, let me rearrange this. ST by OT is equal to OT by OP. Similarly, QP by PT, PT by OP. Okay, I have some terms. Let me define the other triangles. So we have other triangles. Now first ST by OT. So here look at this triangle, OST, right angle triangle. I have brought it here. Some correction is there. Now look at this triangle. In this triangle, what is sine A? You write it as, or ST by OT. Sine A should be equal to ST by OT. So in place of ST by OT, I'll write it as sine A. or no, sir, little bit confusion. Let me write it. Nearby the triangle, I'll write it. Sin A equal to ST by OT. Then look at this triangle. Here, this one. OTP. OTP. I just brought it here. Sin B is, so cos B. Cos B, you can write it as OT by OP. Cos B. So therefore, OT by OP is what? I'll write cos B. Then I'm asking you to get this triangle. P TQP. This one. TQP. No. So anything Q it is, not O. I'll change the symbol. No. Sine here. QP by PT, that one. So this will be cos A equal to QP by PT. Cos A equal to QP by PT. So in place of QP by PT, I can write cos A. Then similarly, PT by OP. So PT by OP, which triangle? PT by OP. I think we have this triangle. Sin B is equal to PT by OP. With a green color, I'm trying to highlight nearby. Sin B, sorry. So finally, we ended up like this, the equation. Sin of A plus B is equal to sin A cos B plus cos A sin B. It is again identity. Not just like a formula. It is being derived using coordinate geometry with the help of triangles here. Now, please do learn, when you're learning, learn the reason, not just like mere going for the formula. Okay, similarly, what we can do is like a sin of A minus B, we can derive cos of A plus B. So cos A cos B minus sin A sin B. Then cos of A minus B, we can write it as cos A cos B plus sin A sin B. The expansion, again, the same mathematics is what you have to take help of. So I think it's not my job to explore all these things. So your math teacher will explain all this, how cos of A plus B is cos A cos B minus sin A B, like how we have brought a proof. No, similarly, we can explore all the proofs that you going to learn in the mathematics. So this is like a sin of A plus B formula, sin A cos B plus cos A sin B. Sin of A minus B, sin A cos B minus cos A sin B. Cos of A plus B, cos A cos B minus sin A sin B. Cos of A minus B is cos A cos B plus sin A sin B. These are the identities you have to remember, very important. Now, similarly, sir, tan of A plus B. We know tan theta, sin theta by cos theta. So I'll write sin of A plus B by cos of A plus B. Sin of A plus B, we have this expansion. Cos of A plus B, I have expansion. I think let me magnify. Yeah, you can. So cos of A plus B expansion, cos A cos B minus sin A sin B. I'll divide and multiply this by cos of cos A cos B. Here cos A cos B, here both numerator divide, both divide and multiply by cos A cos B. Numerator denominator, I'll multiply by cos A cos B here. Here it will come like this, cos A cos B, cos A cos B. Dividing and multiplying. Okay, this is the bracket term. Okay, can we rewrite that's in this form? Sin A cos B plus cos A sin B by cos A by B, cos both are same. Huh? This one. Let me rearrange this one. These things. Sin A cos B by cos A cos B. cos A sin B by cos A cos B. I think this may not be needed. Unnecessary confusion for you. Sin A cos B, sin A cos B by cos A cos B, cos A sin B by cos A cos B. Similarly, cos A cos B by cos A, this one here, cos A cos B by cos A cos B, sin A sin B by cos A cos B. So these two will cancel out. Cos B cancels, cos A get cancels. So sin A by cos A is what? Tan A. Sin B by cos B is tan B. Sin A by cos is tan A, yes. Sin B by cos B is tan B. So tan A plus tan B, 1 minus tan A. So tan of A plus B is what we can write. Tan A plus tan B, 1 minus tan A tan B. There's one more identity is what we have derived. Tan of A minus B. So again, similarly, you can proceed here. So tan of A minus B will be 1 minus tan A minus tan B by 1 plus tan A tan B. Here, this signs you. So how this is brought? Again, the procedure is same. So these are the trigonometric identities is what we have learned it. So we will